For nearly 2 decades, Iran hid its most dangerous secret under a mountain, betting that raw stone and reinforced concrete would outlast anything America could build. That bet just failed, and now the United States is building something even more terrifying to make sure it never works again. Deep beneath the city of Qom, carved into the side of a mountain near the town of Fordow, sits one of the most fortified pieces of engineering on the planet. This is not a bunker in the ordinary sense. It is a fortress buried under nearly 300 feet of solid rock, reinforced with layers of specially engineered concrete and ringed by air defense systems designed to shoot down anything that comes close before it ever reaches the surface above the facility. Iranian engineers chose this site deliberately. After Israel destroyed Iraq's nuclear reactor in 1981 and did the same to a Syrian facility in 2007, Tehran learned a hard lesson. Anything built above ground, no matter how well defended, could eventually be found and destroyed. So, Iran went underground, literally, burying its most sensitive nuclear work where conventional airstrikes were never meant to reach. For years, that strategy worked. Israel's most powerful bunker-busting bombs, even ones weighing thousands of pounds, could not come close to punching through the mountain-protecting Fordow. Iran's confidence grew with every passing year. Engineers didn't just rely on natural rock either. They developed their own ultra-high-strength concrete, some of it tested to withstand pressures far beyond what standard reinforced concrete could handle. In simple terms, Iran wasn't just hiding behind a mountain. It was hiding behind a mountain reinforced with some of the toughest man-made materials on Earth. And for a long time, that combination seemed unbeatable. Then came the moment everything changed. In June of 2025, the United States carried out a strike unlike anything seen before in modern warfare. Operation Midnight Hammer sent B-2 stealth bombers deep into Iranian airspace, and they were carrying the only weapon on the planet believed capable of reaching Fordow. That weapon is called the GBU-57, better known as the Massive Ordnance Penetrator, or simply the MOP. This is not a normal bomb. It weighs roughly 30,000 pounds, about the same as a loaded city bus, yet it is shaped into a narrow cylinder just over 20 feet long, designed purely to punch through earth and concrete before detonating at a calculated depth. Only the B-2 Spirit, and now the newer B-21 Raider, can even carry this weapon, and each aircraft can only hold 2 at a time. During that strike, American bombers dropped a dozen or more of these massive bombs directly onto Fordow, stacking hit after hit into the same points on the mountain in an effort to drill deep enough to reach the underground halls below. Reports later confirmed that 6 bombs were required at a single strike point just to achieve the penetration needed, with each explosion widening and deepening the crater before the next bomb could go further. Additional bombs struck Natanz, another key nuclear site, while cruise missiles hit surface targets at Isfahan. President Trump announced that the sites had been, in his words, completely and totally destroyed. It was framed as a devastating and decisive blow to Iran's nuclear ambitions, a demonstration that no facility on Earth, no matter how deeply buried, was truly safe from American air power. But almost immediately, doubts began creeping in. Independent analysts and even some intelligence assessments questioned whether Fordow had actually been destroyed, or whether the strike had only damaged the upper sections, while the deepest chambers remained largely intact. Iran's own concrete, remember, had been engineered specifically to resist exactly this kind of attack, rated at strength levels far beyond what the bomb's builders had originally designed it to defeat. The rock surrounding the facility added even more resistance, with some sections reaching compressive strength levels that pushed the MOP's penetration capabilities to their absolute limit. In other words, the most powerful non-nuclear bomb in the American arsenal may have been fighting a mountain that had, in some very real sense, been built to survive it. Then the story took an even stranger turn. Iranian officials began claiming that unexploded American bombs remained lodged inside Fordow, creating safety hazards that were complicating international inspections of the site. Iran's foreign minister publicly stated that these unexploded munitions were a genuine barrier to allowing inspectors back in. Some reports out of Iran went even further, claiming that intact GBU-57 bombs, along with thousands of other unexploded munitions, had actually been recovered from the strike zones. If true, that would hand Iranian engineers something almost as valuable as surviving the attack itself, a real, physical, intact example of America's most advanced bunker-busting technology to study, take apart, and potentially learn from. This would not be the first time Iran turned a captured piece of American hardware into a long-term advantage. Back in 2011, Iran captured a single-downed American stealth drone, and within a decade, the capture helped fuel an entire generation of Iranian stealth drone technology that Iranian forces still use today. A single recovered bomb, even a damaged one, can teach engineers an enormous amount about guidance systems, fusing technology, and structural design. For the Pentagon, this created a deeply uncomfortable problem. The strike on Fordow was supposed to prove that American conventional weapons could defeat even the most hardened underground facility on the planet. Instead, it exposed just how close America's most powerful bomb had come to its own limits. Every bomb used in that strike also came at enormous cost, with each GBU-57 priced at several $1 million, and production of new ones bottlenecked by specialized manufacturing processes that cannot simply be scaled up overnight. Reports suggested that fully replenishing the bombs expended during the strike could stretch out for years. In short, the United States had used a significant portion of its entire bunker buster arsenal on a single facility, and there was no guarantee the job had actually been finished. So Washington did what it has always done when a weapon reaches its limits. It started building something worse. The answer emerging from the Pentagon is officially called the Next Generation Penetrator, and it has now been given a formal designation, the GBU-76. On paper, this new weapon looks like a step backward from the GBU-57. It is expected to weigh somewhere between 20 and 22,000 pounds, lighter than the 30,000-pound MOP it is designed to replace. But that reduced weight is not a downgrade. It is a deliberate redesign meant to fix the exact problem exposed at Fordow. The current MOP can only be carried by the B-2 Spirit, and even that aircraft can only lift 2 of the giant bombs at once. As America's shifts toward its newer B-21 Raider bomber, a smaller and stealthier aircraft, engineers realized the Raider would likely only be able to carry a single MOP due to its size. A lighter, smarter successor changes that math entirely, potentially allowing the newer B-21 fleet to carry more weapons per mission, strike more precisely, and hit the same target with far greater efficiency than simply dropping bomb after bomb in the same spot and hoping for enough cumulative damage. What makes the GBU-76 genuinely frightening is not just its weight, but what engineers are building into it. Unlike the current MOP, which must be dropped essentially straight onto a target and relies purely on gravity and mass to punch through rock, the new penetrator is reportedly being designed with the possible addition of a rocket motor. That would allow the bomb to be launched from a distance rather than dropped directly overhead, letting the bomber release its payload while staying further away from enemy air defenses, then have the weapon accelerate itself into the target with far greater terminal velocity. More speed at impact means deeper penetration, even with a lighter overall weapon. It is, in essence, an attempt to beat Iran's mountain, not through raw mass, but through smarter physics. The guidance systems being developed for this new weapon are also a significant leap forward. Engineers are targeting an accuracy level of just over 2 meters from the intended target point. They are specifically designing the system to remain accurate even in environments where GPS signals are jammed, degraded, or completely denied, something increasingly common in modern conflict zones, where adversaries actively try to blind precision weapons. Some versions under discussion also include embedded fuse technology capable of detecting structural voids as the bomb drills downward, essentially allowing the weapon to sense empty chambers or weak points inside a target and adjust its detonation timing for maximum destructive effect deep underground, rather than exploding based on a simple preset depth. Boeing, the same company behind the original GBU-57, has partnered with Applied Research Associates to design and build this successor, with prototype testing already underway in underground facilities, tunnels, and hardened test sites meant to simulate exactly the kind of target the weapon will eventually be used against. The Air Force has already poured tens of millions of dollars into the program, with full prototype demonstrations expected within the next couple of years. Some of the same lessons learned from the actual strike on Fordow, including how Iran's concrete and rock performed under real combat conditions, are reportedly being fed directly into how this new weapon is being designed. Meanwhile, Iran has not been sitting still either. Since the strike's satellite imagery has revealed new construction efforts at other Iranian facilities, including a site known as Talagan 2, where fresh concrete and freshly disturbed soil suggest Iran is already working to bury sensitive infrastructure even deeper than before. Iranian engineers appear to be doubling down on the same strategy that guided Fordow in the first place, betting that if one mountain wasn't enough, an even deeper one might be. This is the uncomfortable truth sitting underneath this entire story. Depth has become one of the cheapest and most effective forms of defense available to any nation trying to protect a nuclear or military program from airstrikes. Digging a tunnel deeper into a mountain costs a tiny fraction of what it costs to build and deploy the kind of stealth bombers and specialized bombs needed to reach it. So while Iran keeps digging, America keeps building bigger, smarter, and more precise ways to reach whatever gets buried. It is a slow, expensive, technological arms race being fought almost entirely out of public view. One side pouring concrete and stacking rock, the other side redesigning bombs from the ground up. If you're enjoying breakdowns like this one, make sure you hit the like button and subscribe, because we cover stories exactly like this one every single week, pulling apart the technology and strategy behind the biggest conflicts shaping the world right now. What's particularly striking about the Fordow episode is how it reveals the actual limits of even the most advanced conventional weapons on Earth. For years, the GBU-57 was treated almost like a mythical weapon, something so powerful that no facility could possibly survive contact with it. The strike on Fordow shattered that illusion, not because the bomb failed outright, but because it revealed just how close modern hardened targets can push even the best weapons to their absolute breaking point. Iran's engineers didn't need to stop the bomb entirely. They only needed to make it work hard enough and expensive enough that doubt remained about whether the job was actually finished. That uncertainty is, in many ways, more valuable to Iran than actually stopping the attack. As long as inspectors cannot confidently confirm total destruction, and as long as questions linger about unexploded ordnance and recovered technology, Iran retains a kind of strategic ambiguity that complicates diplomatic pressure and buys time. It becomes harder for the international community to fully verify the state of Iran's nuclear program, which in turn makes sanctions relief negotiations and inspection agreements far more complicated. A buried, half-confirmed outcome creates more diplomatic friction than a clean, obvious victory or a clean, obvious failure ever could. For the United States, the response has never really been about giving up on the idea of bunker-busting weapons altogether. It has been about refusing to let a single successful, if imperfect, strike become the ceiling of American capability. The GBU-76 represents an attempt to make sure that the next time a facility like Fordow needs to be reached, it won't take a dozen bombs stacked on one after another in days of uncertainty about whether the job actually worked. Engineers want a weapon that goes further, hits harder, and does it with far fewer aircraft and far less exposure to enemy defenses along the way. There's also a broader signal buried inside this entire story, one that extends well past Iran. Nations around the world, including China, Russia, and North Korea, have all invested heavily in deeply buried command centers, missile silos, and hardened military infrastructure over the past 2 decades. Whatever lessons the Pentagon draws from Fordow and whatever weapon eventually emerges from the next generation penetrator program will not be built with only Iran in mind. It is being designed as a tool capable of reaching any adversary's most deeply buried secrets, anywhere in the world, which is exactly why so much of the program's technical detail remains classified and hidden from public view. The origins of the GBU-57 itself help explain why replacing it is such a massive undertaking. Work on the bomb actually began back in the early 2000s, developed jointly by Boeing and the Pentagon's Defense Threat Reduction Agency, specifically to solve the growing problem of buried nuclear and chemical weapons facilities. It was originally treated as a rushed, urgent need weapon rather than a fully planned program, and it went through multiple design upgrades over roughly 15 years before Operation Midnight Hammer became its very first real combat use. That alone is a remarkable fact. A weapon built and refined for over 2 decades had never actually been tested against a real enemy target until it was sent against Fordow, meaning the strike doubled as both an attack and a live experiment on whether all those years of engineering theory actually held up against real granite and real reinforced concrete. The bomb's internal design reflects just how much engineering went into solving this narrow problem. Roughly 80% of its 30,000-pound weight is simply hardened casing, purpose-built to survive the incredible stress of smashing through rock and concrete without breaking apart before reaching its intended detonation depth. Only about 20% of the bomb is actual explosive material, somewhere between 2 and 2.5 tons of high explosive, packed into the nose section. When that explosive finally detonates, it releases somewhere close to 900 megajoules of kinetic energy, an amount of destructive force that is difficult to even compare to conventional explosions most people have ever witnessed. The fusing system inside the bomb is considered one of its most advanced features, capable of being pre-programmed to detonate at a very specific depth, and newer. Variants are even designed to sense structural voids as they punch downward, essentially letting the bomb count floors as it falls before choosing exactly when to explode. It's also worth understanding that the GBU-57 was never the only bunker-busting weapon in the American arsenal, just the largest one. Smaller weapons like the 5,000-pound GBU-28 and the newer GBU-72 have been used for years against far less hardened targets, including underground weapons. Caches used by Iranian-backed militant groups. But none of those smaller weapons ever came close to the depth or hardness needed to threaten a facility like Fordow. That gap between smaller bunker busters and the massive 30,000-pound MOP is exactly the space the next generation penetrator is trying to fill, aiming for something powerful enough to threaten the deepest facilities on Earth, while still being light enough and precise enough to be carried in greater numbers by a wider range of aircraft, including the upcoming B-21 fleet. Iran's response to all of this hasn't been limited to just concrete and rock either. In the months following the strikes, Iranian state media and defense outlets began showcasing a new generation of ballistic missiles specifically retrofitted with Earth-penetrating warheads of their own designed to strike buried military infrastructure belonging to its adversaries. Iranian engineers reportedly achieved breakthroughs in high-strength steel alloys and dense composite materials capable of surviving extreme impact forces, allowing missile warheads to punch into hardened targets before detonating, rather than exploding on impact at the surface. This mirrors almost exactly the same underground arms race playing out on the American side, except flipped in the opposite direction, with Iran now developing weapons meant to threaten buried command centers and military installations belonging to the United States and its regional allies. This tit-for-tat escalation says something important about how modern warfare is evolving. It is no longer just about who has the most advanced fighter jets or the largest navy. Increasingly, entire military strategies are being built around what can be hidden underground and what can eventually be dug back out through brute force engineering. Iran digs deeper into mountains to protect what matters most. The United States builds smarter, faster, and more precise weapons to threaten to reach it anyway. Meanwhile, Iran develops its own underground strike missile technology aimed squarely back at American and allied infrastructure. Every move on one side quietly produces a countermove on the other, and very little of it plays out anywhere the public can actually watch in real time. There's also a financial dimension to this race that rarely gets discussed outside of defense budget hearings. Every GBU-57 dropped. During Operation Midnight Hammer cost several $million apiece, and the Pentagon has already signed contracts worth tens of millions of dollars just to replenish spent tail kits, guidance components, and fuse assemblies from that single mission, with some of those deliveries not expected to arrive until the end of the decade. Developing the next generation penetrator adds an entirely new layer of spending on top of that, with tens of millions already allocated toward prototype design and testing, and far more expected once the program moves toward full production. Multiply that kind of spending across missile defense systems, stealth bomber fleets, and satellite reconnaissance needed to even locate buried facilities in the first place, and it becomes clear that reaching a single mountain in Iran has already cost the United States an extraordinary amount of money, with the true final bill still years away from being fully known. Israel, for its part, has been watching this entire saga just as closely as Washington. Lacking any bunker-busting weapon remotely close to the power of the GBU-57, Israel has, instead, pushed hard for closer defense cooperation with the United States, while simultaneously accelerating work on its own missile defense systems designed to intercept whatever Iran might eventually launch back in retaliation. Some reports suggest Israeli officials have even discussed the possibility of eventually acquiring next-generation bunker-busting technology of their own, though any such weapon remains years away if it happens at all. For now, the ability to reach a target as deeply buried as Fordow remains a capability that belongs to exactly one country on Earth, and Washington appears determined to keep it that way, even as the specific weapon capable of doing it continues to evolve. For now, the mountain at Fordow still stands, scarred and cratered, its true condition still debated by analysts who have never actually been allowed inside to confirm what survived and what didn't. Iran continues to insist its program remains intact enough to matter. The United States continues building toward a future weapon designed specifically to make sure that claim never holds up again. Somewhere between a mountain full of granite and concrete and a bomb still years away from full deployment, the next chapter of this standoff is already being written, quietly underground, far from where anyone watching from the surface can actually see it happening. Before you go, don't forget to subscribe so you don't miss the next breakdown, because stories like this one are only going to get bigger, as this race between buried defenses and the weapons built to reach them keeps accelerating in the months ahead.